Please subscribe, follow and like engineeringall.com. What you should know about aircraft wings. In this video, we will be discussing the following. What are aircraft wings, or what comes to your mind when you hear that word aircraft wings? Parts of an aircraft wing. Stresses that affect aircraft wing structures. Composition/components of the aircraft wing structure. Materials used for the construction of aircraft wings. The making of the aircraft wings. How the aircraft wings are transported. Now let us proceed. What are aircraft wings? Aircraft wings are what differentiate aircraft from other transport vehicles. Long before engines were developed, there was a clear understanding that wings would be required to generate lift for flight. Just like for birds, wings would be what aircraft would need to soar above the ground. Aircraft wings also house the fuel tanks, engine nacelles, sometimes, and components that are used to control flight, so they offer more to the aircraft than just the ability to generate lift. NB, aircraft in this video refers to only airplanes, not all flying vehicles. In this video, I will cover everything you need to know about aircraft wings. All you need to know aircraft wings. Basic explanation of the wing design. The various parts of the wing. Stresses affecting the wings. What makes up the wing structure? Materials used to construct the wing structure. How the wing structure is made. How the completed wing is transported. Aircraft wings are required to have more aerodynamic efficiency than any other part of the aircraft. This means they must be able to generate far more lift than they do drag. Thus great care is taken to ensure a smooth outer structure of the wing as well as a very lightweight structure. Although longer wings come with some aerodynamic benefits, the wing shouldn't be too long because of the additional weight it would bring and consequently, fuel burn. If the wing must be longer, the material, used to construct the wings must be lighter. There are also practical reasons for length restrictions such as landing in airports or parking in hangars. This informed Boeing's decision to make the folding wing design on the B777X aircraft that allows it to be 23 feet longer than its predecessor, the B777-300ER. The wing is folded during takeoff and landing and extended to its full span when it is above ground. The design of the wing is suited to the type of aircraft, the lift required, and aircraft application. What I mean by the latter is that the wing designs required in civilian flight are different from that of military flight, which typically operates in the supersonic region. Wing designs can have straight leading and trailing edges or tapered edges. The wings of passenger aircraft are usually tapered, meaning they are narrower at the tip than at the root being where the wing meets the fuselage, main body, of the aircraft. The wings can be attached to the fuselage at the top, middle, or bottom. For larger passenger aircraft, the bottom attachment is usually the case. Parts of an aircraft wing. Aircraft wings have different parts that make it up, such as the wing structure itself. This is the frame of the wing, which will be explained in more detail in a later part of the video. Fuel tanks. Engine nacelles. These are the aerodynamic pods that house the aircraft engines. They are sometimes attached to the wing, but they can also be found at the rear of some aircraft. Winglets. Most modern commercial aircraft now have winglets or some other form of wingtip devices, for the purpose of improving the fuel efficiency of the aircraft. Landing gear. Some wings have points at which the landing gear of the aircraft is attached. Otherwise, the landing gear is attached to the fuselage. Flight control surfaces. These are components that help the aircraft change its attitude in the commanded direction. Primary flight control surfaces cause the aircraft to move about its three axes of rotation. The ailerons, which are used to roll, are the only primary flight control surfaces on the wing. There is one of them on either wing. Secondary flight controls such as flaps, slats, aka leading edge flaps, spoilers, and so on are all part of the wing. They are used to control the amount of lift and drag generated. Control surfaces are fitted into the wing design and covered with white panels which are visible on the outside. Computer systems and sensors. These help relay commands from the cockpit to the control surfaces and information about the state of the control surfaces, fuel tanks, etc. to the cockpit. Fairings. They are placed at the tip of wings to streamline the airflow coming through the back end of the wing. Stresses that affect aircraft wing structures. The wings are subjected to lots of aerodynamic loads which impose stresses on their structure. These loads change with respect to magnitude and direction as the pressure distribution along with the wing changes during the different phases of flight. Moreover, when maneuvers are performed, the stresses on the airframe are greatly increased. The term maneuvers refers to sudden turns or attitudes the pilot might make the aircraft take on during the flight. When the lift is generated by the wing, it bends the wing upwards, creating a bending moment that has the corresponding compression in the top part of the skin and tension in the bottom part of the skin. Imagine pulling a piece of clothing upwards from both sides. The threads at the bottom part of the cloth will be stretched, tension, while the threads of the top part of the cloth will be made to squeeze inwards, compression. This is similar to what happens to the wing structure during bending. Conversely, when the aircraft is on the ground, the wing tends to bend downwards, so there is tension at the top and compression at the top. The gravitational pull on the wing is responsible for the downward bend. During turbulence, both compression and tension stresses can be experienced by the top and bottom skin parts. The wing structure also experiences some torsional, twisting, and shearing stresses during flight. The wing needs to be able to withstand all these stresses. Some of these stresses are oscillatory, constantly varying about a fixed value, in nature. This introduces another type of stress called fatigue stress, which can then worsen the corrosion of the structure. This is particularly the case for metallic structures. Composition/components of the aircraft wing structure. The structure of the wing is such that adequate support is provided and loads can be transferred easily between the wing elements to preserve its structural integrity. The wing structure or wing frame comprises three main elements. The skin, this is the outer covering of the wing, on the top and at the bottom. In order to maintain the low weight of the wing whilst still preserving structural integrity, the skin is thin while there are stiffeners along and across the wing, ribs and spars. The skin is the first part of the wing to experience the stresses of the aerodynamic loads. It then transmits these loads to the ribs. Ribs run chordwise of the wing from leading edge to trailing edge. Ribs increase the buckling stress of the skin and transmit the loads from the skin to the spars. They also maintain the consistent aerofoil shape of the wing. The ribs themselves are shaped like aerofoils. Spars are beams that run spanwise of the wing. They resist the bending of the wing since they are designed to have great bending strength. They also take up the bulk of the loads. In the event of an overload of the wing, the spars transmit the excess load to the fuselage. Some wings also have false spars to support the ailerons and flaps. Aside from these main elements, there are longitudinal stringers and bulkheads in the structure. The stringers run spanwise like the spars and increase the buckling stress of the skin even more. The bulkheads run chordwise and help to redistribute the loads around the structure. The arrangement of the wing structure ensures the wing structure is sufficiently rigid, but still with a little flex. This flex allows the wing to suppress the gusts of wind and sudden changes in aerodynamic loads that might occur during flight, allowing for a smoother flight. Materials used for the construction of aircraft wings. The materials used for constructing wings must have low weight, high corrosion resistance, and high tensile strengths. The tensile strength must be higher than the highest possible conditions experienced during flight to ensure maximum safety. The metals used in wing structures must have low fatigue crack propagation to lessen the effect of fatigue stress. The most common materials used in the construction of wings are thus aluminum alloys, which are specifically suited for aerospace use. However, composites, particularly carbon fiber reinforced polymer, CFRP, are becoming increasingly popular. Ultramodern aircraft such as the Boeing B-787 Dreamliner and the Airbus A350 have wings that are almost entirely made of carbon fiber. Composites are made of fiber material infused within a resin matrix. Composites are lighter than aluminum and can be tailored more specifically to meet the requirements of the part it is to be used. However, they are more expensive and complex to produce. They can cost more than 60 times more per pound, compared to aluminum. Composites are corrosion resistant unlike metals, but they can absorb moisture which then weakens their bonds. For wings that combine both aluminum alloys and composites in their structure, the aluminum alloys are used to make ribs while composites can be used for the wing skin and flight control surfaces. The making of the aircraft wings. The wing design is first modeled using computer-aided design, CAD, software, then simulations are performed on the model to analyze the flow interaction around it. Once the design is modified to taste and approved, the physical work of putting the wing together begins. The wing parts are assembled in the following steps. 1. Metallic frames of spars, ribs, and so on are first assembled. 2. Flight systems are added. 3. Control surfaces are added. 4. Fuel tanks are added. 5. Engine nacelles are added. 6. Wingtips are added. Wingtips are separate from the main wing structure, for larger aircraft, because of their susceptibility to damage. They are usually made of aluminum alloys. When fuel tanks are not used, joints surrounding where the fuel is kept within the wing structure must be carefully sealed with fuel-resistant sealants. At the wing assembly line, the parts are added and tested before being sent to aircraft assembly facilities. Fasteners, rivets and bolts, are used in the making of wing structures. Their joints form key determining elements of the integrity of the wing frame. Holes are drilled very carefully so that their diameters can be accurate and their axes can be normal, perpendicular, to the skin. Some regions of the wing that are highly stressed have their holes manually reamed out. The rivets must completely fill out the holes they are put in and also create compressive stresses in the material surrounding it. Thus, precise calculations and installments are made. The size of the fasteners and thickness of the skin is also carefully selected by structural engineers to ensure they are able to withstand the stresses they are expected to bear. Rivets and bolts are two-side fasteners, meaning to install them, the tool or machinery used must be able to get to both sides of them. Machines with C-clamps or traveling beam setups are thus used. They are able to go around the structure and apply the required force for compressing the rivet. The machine heads operate on the structure in the following steps. Drill hole. Chamfer hole. Ream hole. Lubricate hole. Tighten rivet/bolt. Install rivet/bolt. After drilling is performed, care must be taken to ensure there are no burrs on the other side. Such burrs could puncture the paint when the skins are fastened together. Thousands of fasteners are used in the wing structure. Composite structures are bonded into large sub-assemblies, rather than riveted. However, the final assembly of the wing structure would still require installing rivets and bolts. How the aircraft wings are transported. Aircraft manufacturers have facilities dedicated to just wings. Boeing, the American aircraft manufacturer, has its facility in Everett, Washington, while Airbus, the European manufacturer, has its facility in Broughton, Wales. The facilities are very large, considering they have to be large enough to accommodate the very large wingspans. Airbus's facility covers over 900,000 sqft while Boeing's facility covers over 1.3 million sqft. The wings are transported from the wing assembly lines to the aircraft assembly lines using Airbus and Boeing jumbo freighter aircraft. These freighters are even bigger than their famous double-decker aircraft, the A380 and B747 respectively. Airbus operates the Beluga and the newer Beluga XL for carrying its wings from Broughton to Toulouse in France or Tianjin, China. Boeing uses the Dreamlifter, a modified version of its B747 aircraft. It is so named because it carries parts of the Dreamliner. The wings are carried by the Dreamlifter from Everett and other small aircraft parts from Europe and Asia to Charleston, South Carolina for the final assembly of the aircraft. This is all the basic stuff you need to know about aircraft wings. I definitely hope this video satisfied your curiosity about the operation, construction, and part.
For watching, please hit the red button to subscribe for more videos. Please follow and like engineeringall.com in all social media.